Laboratory test. Laboratory test. Laboratory test. In quasi-elastic rocks, the stress strain relationship is along a straight line till the point of failure occurs. They are massive, dense, and non-foliated of igneous rocks and metamorphic rocks like granites, gabbros, dolerites, basalts, and quartzites. Such rocks have E values ranging from 610 to 1110 kg per centimeter square. Coarse grained granites, dolomites, sandstones, etc. come under this group. Their E value ranges from 410 to 610 kg per centimeter square. In non-elastic rocks, the stress strain ratio tends to break into initial zone to have a steep slope followed by a curve of a re-slope. There are porous and coarse grained. The E value is less than 410 kg per centimeter square. Triaxial test. Laboratory test. Laboratory test. Triaxial test. The triaxial test is meant to determine behavior of rocks to confining pressures. To perform this test, pressure cells consisting of metallic container into which oil or liquid at a pressure can be inserted are used. The test specimen is a cylinder of L by D ratio 1. This specimen is kept in cell and put the vertical load as a usual uniaxial compression. A series of similar tests are carried out with the A series of similar rocks are carried out with different confining pressure using new test specimens of the rocks. The values for shearing strength, cohesion, and angle of friction for the tested rock can be obtained from this envelope using this equation. S is equal to C plus sigma tangent theta, where S is equal to shear strength, C is equal to cohesion, sigma is equal to normal strength, and theta is equal to angle of internal friction. Improvement of competency of sites. It often happens that due to socio-economic and other related factors, an engineering project may have to be built on rocks or soils which are not ideal and in some cases which may have geological defects too. Tests for rocks used as aggregates. Small fragments of crushed rocks used for various purposes such as concrete making, road material, and railway blast can be termed as aggregate. Tests for rocks used as aggregates. Small fragments of crushed rocks used for various purposes such as concrete making, road material, and railway blast can be termed as aggregate. Required or desirable properties of aggregates, which are nearly the same for all purposes, are as follows. They should not react with cement used. They should have satisfactory hydrophobic properties. These properties are test is now described as to ascertain suitability of locally available rocks for the purposes, particularly as road matter. The property also the properties are they should possess the necessary hardness for durability. They should be tough. They should have high crushing strength. Hardness test. Such tests are important because aggregate which used as road materials invariably undergoes slight shaky movements under heavy momentary but frequent dynamic load due to vehicular traffic. This causes mutual attribution of aggregate material. Therefore, if the rock pieces are not sufficiently hard that resistant to action of attrition, they will cause rapid wear and tear of road material. In addition to the foregoing, the double action of moving wheels of vehicles over the aggregates is also important because it causes abrasion of the rock material. Attribution test. The stone to be tested is broken into pieces of 60 mm size. They are dried well at temperature 100 to 110 degrees Celsius. If the specimens are tested wet, they give less accurate results than when dry. Therefore only dried is tested. Such pieces weighing 5 kg are put in both the cylinders of Devil's attribution testing machine are closed. The diameter and length of these cylinders are 20 cm and 34 cm respectively. They are in an inclined 30 degree with a horizontal position. The cylinders are always to rotate for about 5 hours at a speed of 30 rpm. During this process, rogue fragments undergo attrition. The rogue fragments are taken out and passed out to receive a 1.5 millimeter size. The material retained on the sieve is weighed. The loss in weight of the aggregate gives the measure of resistance of the aggregate to attrition. The percentage of wear is given by loss in weight plus initial weight into 100. This is for DeWalt's attrition testing machine. In the attrition test, if the wear is more than 3%, the stone is not satisfactory. If wear is equal to 3%, the stone is just tolerable. For a good stone, the wear should be less than 3%. Abrasion test. In attrition test, if wear is more than 3%, the stone is not satisfactory. If the wear is equal to 3%, the stone is just tolerable. For a good stone, the wear should be less than 3%. Abrasion test. This test is aggregate is just similar to that for building stone using Darcy's abrasion testing machine. The presence of sand on the pavement is considered to act as abrading material between the traffic wheels and aggregate on the surface, causing additional wear. Abrasion test. This test for the aggregate is just similar to that zone for building stone using Darcy's abrasion testing machine. The presence of sand on the pavement is considered to act as abrasion testing machine. The presence of sand on the pavement is considered to act as abrading abrasion testing machine. The presence of sand on the pavement is considered to act as abrading material between traffic wheels and aggregate on the surface, causing additional wear. Hence, Dory's abrasion test results should be used in estimating the suitability of aggregates for use in the pavement surfaces. The coefficient of hardness is worked out in the hardness test should be greater than 74 stone to be used in the road work. If it is between 14 and 17, the stone is said to be medium hardness. If it is less than 14, the stone is said to be poor hardness, and such as stone should not be used in road work. Los Angeles abrasion test is also considered as a suitable test to assess the hardness of the aggregate used in pavement construction. In doing this test, the clean aggregate dried is the In doing this test, the clean aggregate dried in the oven is put in cylinder of the machine along with a suitable abrasion change. The cover of the machine is fixed tightly and the machine is rotated at speed of 30 to 33 rpm. After 500 revolutions, After 500 revolutions for a fine aggregate, the contents are sealed and the material coarser than 1.7 mm is washed, dried and accurately weighed. The difference between the original and final weights of the sample is expressed as percentage of the original weight of the sample reported as percentage wear. The maximum allowable Los Angeles abrasion test percentage of aggregate is as specified by Indian Road Congress for different methods of construction are as follows. First, 40% for water bound mechanism, 35% for bituminous surface dressing, third 40% for bituminous penetration macadam, 50% fourth 50% for bitumen bound macadam, then fifth 30% for bituminous concrete, and sixth 15% as per ISS for cement concrete. The maximum The maximum allowable loss and abrasion values percentage aggregate as specified by Indian Road Congress for different methods of construction are as follows: 40% first, 40% for water bound macadam; second, 35% for bituminous surface dressing; third, 40% for bituminous penetration macadam; fourth, 50% for bituminous bound macadam; fifth, 30% for bituminous concrete; and sixth, 50% as per ISS for cement concrete. Toughness test. The aggregates material used as road matter not only undergoes rubbing action under wheels or the traffic but is also subjected to constant pounding. It is very important in this context to note that roads may withstand even great loads if they, that is, loads are static or uniform nature, but if the loads are transient, that is, on and of a temporary and are more frequent nature, as in the case of road, metal, or railway blast, the aggregates crumbles very quickly into small pieces. Therefore, it is necessary to test road materials for their resistance to fracturing under the influence of impacts. This is done in the following manner: impact test, impact test for simple stone. For this test, cylindrical test specimen of 2.5 cm and 2.5 cm height is placed on the cast iron anvil or testing machine, which consists of a 2 kg steel hammer falling freely between two vertical guides rods. The blows of hammer are given to the falling freely between two vertical guides or rods, which is toughness test. The blows of the hammers are given to the specimen through a small steel plunger, which are kept resting all time on the specimen. The height of the hammer is increased gradually, starting from 1 cm till the stone breaks. The impact value is taken as the height in centimeters at which the sample breaks. In the impact test, is the value of the toughness index comes below 13. That stone, if this value comes in the compared test, toughness test. The aggregate material used to road matter not only undergoes rubbing action under the wheels of the traffic but is also subjected to constant pounding. Toughness test. The aggregate material used as a road material not only undergoes rubbing action under the wheels of the traffic but is also subjected to constant pounding. It is very important in this context to note that rocks may withstand even great loads if they, that is, loads are static or uniform nature, but if the loads are transient, that is, on and off or temporary, and are of more frequent nature, as in the case of road, metal, or railway ballast. The aggregate crumbles very quickly into small pieces. Therefore, it is necessary to test road materials for their resistance to fracturing under the influence of impacts, and this is done in the following manner: impact test for single stone. For this stone, cylindrical test specimen of 2.5 cm diameter and 2.5 cm height is placed on the cast iron anvil of the testing machine, which consists of 2 kg steel hammer falling freely between two vertical guides rods. The blow of hammer are given to this specimen through a small steel plunger, which is kept resting at all time on the specimen. The height of the fall of the hammer is released gradually, starting from 1 cm till the stone breaks. The impact value is taken as the height in centimeters at which the sample breaks. In the impact test, if the value of toughness index comes below 13, the stone is not tough. If this value comes between 13 and 19, the stone is said to be moderately tough. If it exceeds 19, the toughness of the stone is said to be high. Impact test for aggregates. 5 kg of aggregate of size 1 to 2 cm is taken and subjected to 15 blows from a 15 kg hammer falling from a height of 40 cm. After these blows are given, the fines passing through BSSV C or weight resulted is expressed in terms of percentage of the original weight. The more the amount of fines, the lesser the resistance of the aggregate to pounding. This is impact tester. Aggregate impact tester. This is impact pendulum. This is anvil. This is specimen. This is specimen. Not here. This is specimen. This is hammer. This is scale. This is impact pendulum. In another test, an impact pendulum tester is used. The pendulum of the tester causes impacts on a test specimen held onto an anvil. The pendulum is released for its full swing or form a smaller height. The impact toughness of specimen rock can then be calculated by using the relationship impact toughness is equal to rho by La kilogram per centimeter square, where rho is the energy in the pendulum at the time of impact, L is the specimen length, and A is the cross-sectional area of the specimen. Binding properties. It is necessary that roadstone should possess a good affinity for binding materials to ensure stability. Stones which have the ability to form their own binding material under traffic are desirable. This property is tested as follows. From a finely ground paste or the test specimen, small briquettes are made. After drying, these briquettes are tested by standard hammer. Number of blows required to break the briquette gives the approximate measure of the binding value of that roadstone. In this way, the binding power is described as low if the briquette breaks before 10 or less blows, as fair if it withstands 10 to 25 blows. After this limit, it is turned good up to 75 blows and very good up to 100 blows or more. Crushing strength. From the crushing strength, the ability of aggregate to withstand heavy traffic loads can be judged. The test is done as follows. The aggregates reduced to 1 to 2 cm are dried at 100 to 110 degrees Celsius. About 3 kg of it is placed in a steel cylinder of 50 cm diameter with a closely fitted ram. A load of 40 tons is applied through the compression testing machine. The percentage weight of the resulting fines passing through PSS 7C gives a measure of the crushing strength of the aggregate. Hydrophobic property. When the road aggregates have bitumen tar as the binding material, the shearing strength of the mix largely depends on the degree of cohesion. Hydrophobic property. When the road aggregates have bitumen tar as the binding material, the shearing strength of the mix largely depends on the degree of cohesion achieved by bitumen layer in between the aggregate material. The cohesion is lost in some cases where these aggregates are constantly exposed to water. Quartzite and sandstone being the typical example of hydrophobic materials are unsuitable to be used as road aggregates. The cohesion is lost in some cases where the aggregates are constantly exposed to water. The cause for this loss of cohesion is the affinity of aggregates for water, whereby the bitumen is replaced by corresponding film of water. Cracking of concrete. The superficial cracking of concrete may take place either due to clay content of the aggregate or due to the alkali reaction of the aggregate. In first case, if the aggregate contains certain clay minerals, that is clay minerals of Montmorillonite group, they swell on coming in contact with water, resulting in cracking of concrete. In second case, cracking of concrete may occur due to reaction between alkalis in cement and reactive aggregates. Even then, it is necessary to test the aggregate for this reactive nature. Generally, all silicate minerals produce the gel reaction with a high alkali cement, but only a few react very strong to cause trouble. Whether a given aggregate shall lead to crack of concrete or not can be ascertained by detailed metrological examination of the aggregate. Further, a laboratory test on the concrete made from aggregate and high alkali cement is also desirable, but this requires up to a year for deciding whether a test member bar which is kept in humid atmosphere at a certain temperature in an airtight container has expanded or not. Among other undesirable constituents, iron sulfide minerals like pyrite, marcasite, and pyroxite. The aggregates are deleterious in concrete. They lead to formation of weak acids which are corrosive in nature. It shall be proper to mention here that for making heavy concrete which are used for atomic plants, heavy aggregates are required. Barytes, BaSO4, specific gravity is equal to 4.5, and hematite Fe2O3 specific gravity is equal to 5 are useful in such contests.